Hey guys, this is Dr. Sangeeta and welcome back to another lecture of Dental Pathshala where we help you understand and learn dentistry better and easy way. And today's topic we are going to talk about the gypsum bonded investment, which is a frequently asked question for the students, which is again very important for Viva point of view, very important for NEET point of view. So gypsum bonded investment. In order to understand the gypsum bonded investment, we should know what investment is. Until and unless you have seen the casting, which is very rare, most of the students have not seen the casting procedure. It is actually very difficult to understand, but let me give you an attempt to make you understand this. What happens when the patient comes to us? We take an impression, right? When we take an impression, after taking the impression, when we have to deliver a crown to a patient, then what do? After doing the tooth preparation, we have made a space for the teeth or any metal framework, for example, a framework for RPD, anything which we want to convert it to a metal. How do we convert it? We are going to invest it. So what is the basic procedure? For example, if you want to make anything out of the metal, so what do? You basically build it with a wax, and once you build it with a wax, then later on you are going to make a mold. All of you have seen what a mold is. Mold is basically a cavity is present. That means you are going to make such a box that whatever shape you want to create, either you want to make a ring or you want to make anything, suppose be it is anything, not a crown, anything. So what are you going to do is you're going to create that same pattern with the wax first, and that wax pattern you are going to put it in a box. Basically this is in the layman's term. And then once you are going to put it in the box, then you are going to heat that box. Once you heat that box, that whole of the wax will get melted and you will get empty space inside it. In that empty space, you can pour the molten metal. Once the molten metal is poured properly, it is heated properly, then it is cooled, and then we take out that metal, we finish it, we polish it. This is how the basic casting procedure, basic investment procedure is done. First of all, we make a pattern with a wax. If you want to make a crown, we make a crown with a wax. If you want to make a RPD framework, you make a RPD framework with that. For this thing, you require a cast. This is the reason that we want a cast. So basically, what do? We first prepare with a wax, and then we prepare a mold, and after that we have a mold, then we melt all the wax, we get the space, that is we call the mold, right? That is the space, and then we put the molten metal into it. So this procedure is what do we call the casting procedure. This is basic, very simple. So why are we studying this gypsum bonded investment is that, my lovely students, we are going to put this wax into such a material that if we heat that material, it will not disintegrate. Suppose if I am putting plaster of Paris into it, so what will happen once I am subjecting, I am going to put molten metal first of all. Secondly, to dissipate the wax, to melt the wax, to dissipate the wax, I need to put this particular box in such a high temperature. Suppose if I want to put in 1500 temperature, right? So for that case, I need to heat such a high temperature. What will happen? All of the cast will shrink, right? So there will be no space which is left for the mold, which is left for the molten metal. So for this reason, we prepare investment. We have got investment material. See, investment is you are putting something into it. For example, if you are making investment with the money, investment is a simple term. That means suppose if you are doing any investment, so what do? You put all your money into it, right? So that is the investment. So you are going to put a material which is going to create a space. Which material we are going to talk about now? This material can be a gypsum bonded investment material, it can be a phosphate bonded investment material, it can be a silicate bonded investment material. So today's video we are going to talk about the gypsum bonded investment material. So basically a kind of material which we use for the investment procedure, for the investment. So this technique of melting the wax and making the mold is what we call a lost wax technique. This is also a frequently asked question for Viva, which was given by the Taggart. So this technique, basically we are losing the wax and creating the mold, very simple, is the lost wax technique. And let's start with the gypsum board in investment. So guys, before we get started, make sure you subscribe to our channel and click on the bell icon so that you don't miss any of our exciting videos talking about the gypsum bonded investment. Now we know that we need such an investment material that is not going to distort its shape when we put the molten metal. It is not going to burn out when we are going to burn the wax. Now that we know that we need such a material, so we have got different kind of investment material, casting investment material. It can be a gypsum bonded, it can be a phosphate bonded, it can be ethyl silicate bonded investment material. Why all these material now? Let's understand this by studying today the gypsum bonded investment material. In the gypsum bonded investment material basically is made up of gypsum product. Gypsum product, I hope that you know what a gypsum product is. Basically, it is a calcium sulfate dihydrate, right? So initially it is calcium sulfate dihydrate. Once this is what we get from the nature, then we take this calcium sulfate dihydrate into a manufacturing process into the industry, and then we extract the water out of it. Because why are we extracting? Because already it is dihydrate, my lovely students. How it is going to set? It is already set. We want to use it in the dentistry. We want to apply this gypsum product in case of dentistry. So what do? We take this calcium sulfate dihydrate, right? Dihydrate into the industry, right? This is our industry. Then in the industry, there are many ways to convert it. It can be the calcination process, can be a dry calcination, wet calcination. So all of these are based on how you are going to extract the water. Based on that, the crystal will form. So we are going to take out the water out of it. It is, the same way like how we take the sugar canes to a sugarcane mill and then we extract the sugar out of it. The same way, how we are going to take the water out of it, we are going to heat it, burn it, right? And then after we heat it, we are going to convert it into calcium sulfate hemihydrate. Hemi always means half. This was dihydrate. Now that we have the calcium sulfate dihydrate crystals ready, we are going to pack it in a packet and sell it. That is what we buy it from the dental shops. This is the calcium sulfate hemihydrate. This calcium sulfate hemihydrate, it comes in so many forms. Type 1, type 2, type 3, type 4, type 5, that we'll study in the gypsum bonded investment. So in the process of making this calcium sulfate dihydrate into hemihydrate, we have got two kind of procedures. One is wherein we are putting pressure, right? One is we are putting in a container. It is the same. We are putting in a container, we are putting pressure, applying pressure. The another one is we are just heating in the open container, open vessel. So that kind of open vessel is not that good. This is how the same way we know that once we are cooking anything, if you are cooking in an open flame, if you are not covering anything on the top of it, it will not be boiled properly, right? So it will be kind of dry. So that kind of crystals which we create in the open vessel, we heat in open vessel, open kiln we say, is the beta kind of hemihydrate crystals, which are not that great. They do not have that much of strength. They are not strong enough. So another one which we put in the closed container, then heat it, then we put pressure also. That kind of crystals are alpha, like alpha males. They are very nice and very strong. So these alpha crystals you also use for dye material. Now that is all over a different subject, a different chapter now. So this alpha particles, gypsum bonded, we are going to use for investment material. So this kind of alpha particles, which are strong particles, we also use it for investment material. So what are we going to do? We are going to take this alpha particles of the gypsum product. So we are taking the alpha calcium sulfate hemihydrate crystals. This is the ingredient. This is the main product of the gypsum bonded investment, but it is not the principal ingredient. Let me show you. Now these are these gypsum bonded alpha particles. Okay, understand these. Suppose these are the alpha particles. How they set? They set by intermingling, right? In the gypsum product we know that they intermingle with each other and these particles set, right? So this is also alpha particle, this is also alpha particle. So like that we have what? Alpha particles. What happens once we heat it? Once we heat all these alpha particles, they are going to come and shrink, right? So gypsum bonded investment material, first of all, we can only burn it up to 700 degrees Celsius. More than this, the gypsum bonded investment material will start distorting its own structure. That means it cannot withstand so much of high temperature. So what are we going to use the gypsum bonded investment for? Gold alloys. So for the conventional gold alloys, we use the refractive material, we use the investment material, I must say, the gypsum bonded investment material. So easy trick to learn is that G for gypsum and G represent the gold also, right? First of all, we have got the alpha calcium sulfate. As the name suggests, gypsum bonded. That means the gypsum particle are bonded to each other in the investment material. As I always tell you that you have to look for the name, understand the term. Once you understand the term, you will understand the whole concept. So that means gypsum particle are bonded to each other. That means there is going to be a binder also. Now we know that how this gypsum hemihydrate crystal set once we put the water into it. So once we put the water into it, what happens? They are going to float nicely in the water, swim nicely, but once we heat it, what will happen? They are going to contract, they are going to shrink. For that purpose, how the contraction occurs, that they come close to each other. So particles which was earlier like this, now the particles on heating to such a high temperature, it will become like this. Okay, so there is so much of contraction which happens. So what do? We have to come up with something so that there is no contraction happens. So we put something in between these spaces. Whenever we put a material into empty spaces, we call it a filler material. Filler means it is going to fill the spaces. So whatever the voids are there, we fill these voids. Now you understand this, that the structure of these fillers are very small. So that means if we compare the amount, the calcium sulfate hemihydrate crystals, alpha particles, are less in number, are less in weight, less in percentage, less in volume. If we take the filler material, we need lot of filler material to fill in the spaces. This filler material, usually in dentistry, we use the silica. Now, silica has many forms. It has quartz, cristobalite, tridymite, fused quartz. So all these forms of the silica we use in the dentistry. We use for formation of glass. We use for formation of so many things. Everywhere, resin also, we use the silica particles. So wherever we want to fill the spaces, we put the silica particles. Because the silica particle, it provides the strength. And also, it is not letting the main principal particle to shrink. On heating, they because they are present in the voids, so now these alpha particles, they cannot, when heating to high temperature, they cannot come and combine with each other. That means we have got these spaces we have filled with the silica. Now the silica is the refractive material. How the refractive material? Because it can withstand up to high temperature. What do we call a refractive material? Is when it can withstand a high temperature. So these silica particles are, that is the filler particles, up to 60 to 65%, right? And this calcium sulfate, alpha calcium sulfate hemihydrate crystals, which are the gypsum crystals, are up to 25 to 45%, right? Now what happens? We are putting water. We want that these calcium sulfate particles, they bind with the filler, they bind with the silica, and we also want that they bind with the silica, bind with the water. If you are trying to put sand into water, it will not get dissolved. So the main purpose of why we are not taking only the silica particle, Why are we putting the gypsum at the first place? Your question can be, ma'am, you could have only taken the silica particle, dissolve it in the water. Because my lovely students, if you are trying to dissolve the sand into water, it will not get dissolved, right? So for that we need a binder. We need something to bind the silica particles to the water. For that purpose we are taking the gypsum product, alpha calcium sulfate hemihydrate crystals. Now this calcium sulfate hemihydrate crystal, alpha form of calcium sulfate hemihydrate crystal, which is the gypsum, is our binder in case of the gypsum bonded investment, in case of the casting investment material. So now that we have got the filler, which is the silica, which constitutes 60 to 65%, and we have got a binder, which is the gypsum product, which is the alpha form of calcium sulfate hemihydrate crystal, because beta form cannot take so much of load, that are weak, they are not that strong. See, if I ask a alpha male or a very good bodybuilder, if I ask to do 20 sit-ups, he can do nicely. But if I asked a fat man who is very lazy, lethargy, always watch Netflix, he cannot do it, right? The same way, the beta crystals, they cannot take so much of load. So that is the purpose of us using the alpha calcium sulfate crystals, because they are strong crystals. Also, we put the reducing agent. Now, what is the requirement of reducing agent? We have got the investment material. In that, we have got the mold space, which is created by melting the wax, which is created by the escapade of the wax, right? So this space we are going to put the molten metal into it. So this molten metal, this is the same way we make candles, right? So this molten metal, when we are putting in this empty space, will get oxidized, right? So all these metals, we know that they get oxidized when they are coming in contact with the oxygen. Now also oxygen can take it from the water, because we are mixing this gypsum bonded investment material into the water, right? We'll be using this. This gypsum bonded investment material, it comes in packets. What do? We mix it in the water. What is the water powder ratio? See, always remember that water powder ratio is, you have studied gypsum bonded investment or gypsum material also. In that gypsum product chapter, we have studied about 0.30, 0.40. What is the significance of all that? Always we take 100 gram of powder, and response to that we take the amount of water is that ratio, water powder. When I'm talking about water powder ratio, that means water come first. That means always remember that we are changing the water. So in the gypsum bonded, in the 100 gram of this gypsum bonded investment material, we put 80 ml of water. So if I say that 0.80 is the water powder ratio, then you will understand, right? So this is the 0.80, that is the 80 ml of water. I mix it in the 100 gram of powder. Once I mix it, then there is a reaction which happens. Then this gypsum bonded investment material, it sets. Now ideally it takes 5 to 25 minutes. But nowadays we have got so much of recent advancement coming, so it can set up to 9 to 18 minutes, but still we wait for 1 hour it to get set. Still we wait for 1 hour, and then we put it in the refraction. Then we put it in the furnace. Then we start melting the wax. So what is the purpose? Once we are putting the molten metal, this molten metal will provide oxide layer, right? It will take also from the air oxygen. It will take oxygen from the gypsum bonded investment. We have mixed the water. That is why I told you that we mix water. So it takes up oxygen. It makes an oxide layer. So suppose if it is keep on making the oxide layer, then the metal we get, then the crown we get will not be good, right? So we want to put a reducing agent into the gypsum bonded investment material itself. What is the purpose of a reducing agent? We know that reducing agent, as the name suggests, it is going to get reduced. Reducing agent is so kind that it gives up electron. So always we know that reducing agent, we have studied in the chemistry, that it loses the electron, it gives electron, and it get oxidized itself. So it is the reducing agent is carbon, powdered copper or carbon particles. We put this carbon into this gypsum bonded investment, which is going to reduce the oxide layer forming on the metal. And in this high temperature, it will not let the metal to form the oxide layer on the top of it. So this is the purpose of reducing agent. So we have studied the composition, 3 things: One we have studied is the refractive material, which is the silica. Right, this silica is basically a kind of a filler. See, this is not a resin. If I am telling you resin, then we can use the word filler because we are just filling the space. But here, the filler, we can use the term refractive material instead, because the refractive material is going to withstand the high temperature. It is going to provide the expansion by the thermal expansion. So purpose of silica is that silica is there in between. So silica will not let the gypsum alpha particles contract. So it will give a setting expansion. This is how we use this term. We have studied this term, normal setting expansion. What do you mean by the normal setting expansion? So this silica particle, once the gypsum is setting, it is not letting this gypsum to contract. So it is providing expansion. This is how we tell that normal setting expansion, which is because of the silica particles. Also, once we are heating this alpha calcium sulfate hemihydrate crystals, once we heat it, the silica is also providing the thermal expansion by changing its own structure. So alpha form of quartz is converting into beta form. Also, alpha form of cristobalite structure on heating is converted into the beta form. So like that, the silica is converting its own structure. So that way also, changing its own structure also is providing expansion. How? Suppose what happens that in the winter season, okay, I'm freezing in cold. What happens once you put a heater in my room? Then I'm going to, instead of freezing, I'm going to relax my extremities, I'm going to relax my arms, legs, so I am occupying more space. So you can understand that the alpha form is like a contracted. Once you heat it, it will convert into the beta form, which provides also some kind of expansion. So because we do not want this mold to get contract, otherwise if it get contract, the inside mold space will get reduced. So whatever shape we desire, that will not be completed, that will not be formed. So what does happen is that we need to give some kind of expansion to it. So it is the silica particle which is giving the normal setting expansion. It is the silica particle, when heated, is going to change the shape also, and it will convert it into, from alpha it will convert it into beta, and thereby also it is providing the thermal expansion. Now you understand that what is the meaning of normal setting expansion, what is the meaning of normal thermal expansion, and why do we need all these expansions. Second thing we have studied is the binder particle. The binder particle is our calcium sulfate, alpha form of hemihydrate crystals, which is going to react with water and bind to the silica and water together. This is the purpose of the gypsum, which is the alpha form of calcium sulfate hemihydrate, and also it contribute to the mold expansion by its own setting expansion also it has got. The third thing is the reducing agent we have studied, which is also put it in the gypsum bonded investment material. So we also put this reducing agent, which is usually the powdered carbon, which is going to reduce the oxide layer formation on the surface of the metal. And the fourth thing in the composition of the gypsum bonded investment material is the modifiers. So because we do not want that shrinkage to happen on heating, we put some modifiers. It can be boric acid or NaCl, which is our salt, sodium chloride. So we have studied the composition, we have studied the significance of all these things. Now that I hope you understand what is gypsum bonded investment material. Why are we studying this gypsum bonded investment material? What is the purpose of studying the composition of gypsum bonded investment material? I hope that you have understood it. If you have understood it, then leave a comment in the comment section. Or if I need to improve anything, if you are not understanding it, then I must have to come up with other way to make you understand. So there is a refractive material which we use in form of silica. Silica has many forms. It can be quartz, cristobalite, tridymite, and fused quartz. And because it is a filler, so we use it in 60 to 65%. So basically it is a refractive material. We won't say the filler, we will say that it is a refractive material. The purpose of silica is to withstand the high temperature, where once we are putting this investment into the mold, into the furnace, so it is going to withstand the high temperature, and also it will not let everything shrink. It will not let the shrinkage of the mold because it is providing expansion by normal setting expansion, by thermal expansion. Second thing is we put the binder. The purpose of binder is to bind the silica and the water. Because once we are mixing this, like how we mix the gypsum, right? How we mix the type 2 dental stone, type 3 dental stone or type 2 dental plaster. So when we mix it, we use water, right? So like that, we are going to mix the water and then we are going to put it in the mold space. So the purpose of binder is to bind the silica and the water together. We use the alpha form of calcium sulfate hemihydrate crystals, which is a form of gypsum product. Now, the purpose is to react and also to hold on to the expansion. The third thing we have studied is the reducing agent. We have used powdered copper or the carbon. Now the purpose of reducing agent is the reducing agent itself reduces. Always remember, we have studied in the chemistry also. It gives electron. Okay, it reduces itself. And that means it gives electron and it get oxidized itself. So it is going to reduce the oxide layer which is formed on the metal surface. The last thing is the modifier. Why do we use the modifier? Because we want to inhibit the shrinkage on heating, and we use the boric acid as well as we can use NaCl, which is sodium chloride. Hope that you have enjoyed the video. So if you have enjoyed the video, give it a thumbs up. Also, you can comment in the comment section below. There is a link in the description box below to support me on Patreon as well as on PayPal to make free videos for you guys and to make free notes, which will take some time, but it will be available. So guys, till then, keep reading, keep learning, stay motivated. I'll see you soon in the next video.